Welcome to BeeGraphy. My name is Asim, and in this fifth intermediate tutorial, we are going to continue with the image sampler. Like I said before, we are going to look at Lego mosaic art. So let's get right into it. When you Google Lego mosaic, you will see such kind of images where small Lego blocks can be used to create an image. And this fits in perfectly with what we do in image sampler. In this case, we'll be using the color output of the image sampler node. I have opened up a canvas in BeeGraphy, named it image sampler part B. Type in image sampler. If you haven't watched the part A, I have shown how to get the image sampler plugin installed. So quickly hop onto that and check it out. And once that is done, simply type in image to get image input and then the image sampler. Let me put in the logo of BeeGraphy as the image. That will go into the image sampler. After that, let us create a grid by using construct point. Oops, sorry. Construct point. And put the X and Y like we did before. Click on the magnifying glass to see the grid. Now let's see what comes out of color. If we look at panel, we can see 900 objects, and you see this hashtag 333, hashtag FFF, E5, E5, 4949. So this is another way. This is the hex code that tells the computer what color is to be shown as the output. So as you can see that most of this is slightly grayish in color, and then we've got white and yellow. That's why we are seeing a lot of these numbers to be the same. Right? Let me actually see hashtag 33333. What color does it give? Yeah, it gives us this color, which is the background. And if we give in hashtag 5C, 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 let's see what we get. 5C, 5C, 5C. Oh, it's just slightly lighter color. Interesting. It's probably just at the border between the white and the gray background. And if you go, let's say FFFF, what do we get? Yeah, that's just white, this white color. You can see whenever I'm moving this, we are getting the hex code, which is coming out here. And we're also getting the RGB value, which I explained in the part A of this tutorial. So the color gives out hex codes at each of these pixels, whereas intensity gave us the brightness, the white value, the whiteness value at each of these pixels. So we're going to use this color. But before that, we need to have some geometry over here. Before we create the Lego block, let's just understand how this color applies. I'm going to create a box. Let's say box by center. And give it this origin. Let us give 100 width and length. And let me hide these points. Awesome. So we have all these boxes which are very thin, laid out perfectly. Now I'm going to, give it a material. And by default, the material is white, so we are looking at this. You can make out these different boxes which will act as pixels for our image sampler. And now the interesting thing happens. If we simply connect the color from image sampler to our apply material, we can see the image generated. You remember the second color that we saw, it was slightly grayish, somewhere between white and the background. So this is where it is. And let us increase the resolution by increasing the scale, and you'll understand things even better. So it's computing. Now that size has increased. Actually, I should hide these boxes. Yeah. Amazing. So this is more accurate, and you can do this with any other image as well. Let us do the bird again. We use that for the perforation part. But now we've got this. So it looks like a blurred image, but that's what it is. A blurred image is simply more pixelated. Is what you get. All right, so let's move on to creating the individual Lego blocks. Let's look at Lego single piece dimensions. Yeah, this one. Yeah, I think this is good. So we'll use this as a reference. We've got the height as 9.6 millimeters. This is 7.8. And then we've got a small cylinder that we'll make. So let's first create this cuboid as the base. Let me disconnect it for now. All right. So the idea is we've got the grid that we have, and then we are going to create rectangles and then extrude it up and then cap it off. I think that will be a good approach. So let's do rectangle by center. Yeah, let me just delete this. We're going to keep that, remove this. And then I'm going to do construct. Oh, sorry, the construct point is already here. So we're going to use this point as the origin for all these rectangles. And actually, let's just connect the image anyways. But we'll reduce the scale to just 20 so that we can work with it. And then we'll increase the scale. Let's do 20. So it's still computing. Let me refresh it. All right, so I've refreshed it and now it's working. Yeah, we've got 400 rectangles, 20 by 20. We'll have the gap same as 100, but the same thing will go into the width and length of those rectangles. Let me stop the solver and then connect all of this so that we are a bit quicker. All right, so we've got the rectangles. Now let us there are two ways to go. Either we create a surface, curve to surface, and then we extrude the surface. Right, so this is the surface. Then I'm going to extrude surface, sorry, in the Z direction by a value of this 9.6 meters. But the thing is, I've taken gap as 100. So let's change it to 78. So we'll work in that order. Instead of 7.8, it will be 78. Let's do that. And you can do it 7.8 as well. That won't matter. You see it is automatically rearranging itself. Awesome. So now the gap is 78 units. It is 7.8 millimeters. And the width and length is also 7.8 millimeters. Now we need the height, which is 9.6. So we are going to do 96 in our case. 96. Now we've got the height. All right, 78, 96. And what else? Yeah, so that's it. We've got the base cuboid ready. Now we need to create the cylinder. And just actually to show you that anything is fine, like even this works, or even small order number will work as well. Let me stop the solver. Yeah. And I'm gonna do Control Shift to transfer all of this outputs to 7.8. And this one will be 9.6. And yeah, just remove the bigger order numbers. As soon as I do turn on the solver, everything will shrink by 10 times. Okay. I'm glad this error popped up. You can see it says the value should be greater than or equal to 50. So we cannot have it less than 50. Let me again pause the solver, just Control Z, till we go back to where we were. Awesome. Now let's create that cylinder. Right, so we've got a cylinder. Can simply type in cylinder. The origin will be the top of these rectangles. So that would mean, pretty simple, it would mean it's a point which I'm going to move up by a value of this height. So what I did was I took all the original points and I simply moved them up by a magnitude of the cuboid height. All right, so that becomes the origin for my for all the cylinders. Yeah, this becomes the origin. Getting a bit laggy. The radius. Oh yes, the cylinders have come up. The radius will be, let's see how much it is. It is 4.8 mm. You're going to do it 48. And the height will be, let's see, 1.7, 17. Awesome. Oh, sorry. That's the diameter. This is the diameter, 4.8. I used to do the same mistakes so many times during my school. We call those silly mistakes, and they cost a lot of marks. So awesome, we have achieved the Lego blocks. Let me hide everything else. Rectangles. A bit slow. Now we're going to apply material to both of these geometries, but we're going to do that separately actually. Um, yeah. Okay, so we've got this, and all right, so we should already see. Um, oh, this apply material is hidden, so we are not able to see it. Awesome. Brilliant. So I applied the material of all those colors to the cylinder, and I applied all the same colors to the cuboids. This makes the script pretty lightweight, and we are able to get the image. Let's take something more simple like a logo of BeeGraphy. I love how it just computes and gives us the outcome like the old CRT monitor, cathode ray tube monitor. Um, yeah, I guess this is good. I'm just gonna try to increase the resolution to, let's say, 30. And oh yeah, perfect, it's working. We increase the size. So these are the Lego blocks. You can even add some small spacing between them by, by adding some value to 78 and putting into the gap, but keeping the same 78 value to the cuboid width and height. So that will keep it perfect. Awesome. So that's all. I think this wraps up our Lego tutorial, Lego Mosaic. One other thing that you can do is create the base for it. You can see that in the Lego Mosaic, we place it in a base. You see there is a base. So the base should have protrusions like just like those cylinders, and they will have some thickness. So actually what we can do is simply move the cylinder down or towards the other base and create it. It'll be pretty easy. Let's do that. First of all, we need this rectangle, how big it is. And it's actually pretty straightforward. You see this scale, that means there are 30 units on each side. So 30 multiplied by the width will give us the total length. I'm going to do multiplication 30 and the width, which in this case is this one, and this will become the rectangle. Yeah, let's start from one side and put it as the width and length. Yeah, there is some offset that we need to fix. So I'm just going to shift the origin. I can actually directly input some values, but if I change any of these values, then this thing will fail. So I'm going to do construct point and and I'm going to move this by 78 in the X and Y direction, and let's just see what happens. It's moving in this way, so we need to put in negative that, so we'll put in opposite, and no, this won't work. This goes here, and this goes in 78. Yeah, so negative 78 would be here, and that is too much, so we need to do 78 divided by 2, right? Because half of the square is shifted off, not the whole of it. I'm going to do divide by 2, 78 goes in, divided by 2, and then it becomes negative to give us the perfect final outcome. Now one thing, why are we getting two rectangles? So let me just refresh it. Oh, right, this construct point is getting two values. I need to disconnect it from the original 78. So yeah, I'll do that. Then we'll have a single rectangle. Zoom out. Awesome. So we have a rectangle that is encasing this entire structure. From that, we'll create a surface that will be curved to surface. One. Awesome. And we are going to give it some thickness. Lego base thickness. How much is it? Or is it not standard? Yeah, let's just assume something. Let us assume, since it will be pretty big, I don't think it will be the typical thin base that we see in the normal kit. So let's consider it as thick as our Lego block, which is 9.6 mm. Where is the surface? Yeah, I'm going to extrude the surface, but in the negative direction. By 96 in the Z vector. That goes in the extrude surface. Pretty thick, but I guess it's fine. Now, we need to see the board. So let's move the entire thing down. I'm going to give a negative Z value to the construct point so that the entire plate dips down. Let's move it by, let's say, 300. Awesome. We can even increase that up to us. Now, what we are gonna do is, first of all, let's hide stuff, and we're gonna move this dots, the cylinders, and keep it on the base plate. So how much do we move it down? So there are two dimensions that needs to be added before putting into opposite. One is the height of the cylinder, which is 96, which we can find keyboard height. I'm going to use this. What you're going to add, it's stuck, but you're going to add the distance between these two, the base plate and the Lego blocks. Let's wait for a while. Awesome. The distance is here. Let's rename that distance from plate. Let's clean this script up a bit. Let me stop the solver. Awesome. So the solver is stopped. Now we can script more easily, and I'll reduce the resolution as well, the gap, so that it doesn't get stuck. Let me refresh this. It is very choppy. And I think that's because of probably my internet connection, probably because I'm recording as well as running this. Yeah, now it is so much more better. This part is different. The image sampler, this division goes in here. We will rename, we'll group this and call it Lego blocks. And after we finish the last one, we'll simply group it and call it the base plate. So we are taking the cylinders from top, the top part of the cuboids, the Lego block, and then I'm going to pull it down, copy it, like move it down to the base plate. And the distance between that and the base plate is the distance of the base plate that you're moving, which is over here, distance from plate, and the height of the cuboid. That's why I'm adding both these things, cuboid height and distance from plate. And then I'm putting it into negative, the opposite node, and then putting it into the Z vector. And then I put that to the move. So this is simply the small protrusions where the Lego blocks will fix. And this extruded surface is the base plate. So we'll simply give them some material. And it's fine if we combine it because it will be the same color. And I'm going to hide everything else. Awesome. Let's turn on the solver. Oh, before that, let's do this 20. Let's make this 20. Turn on the solver and see what happens. So those are the Lego blocks that are popping up. This is the base plate. And these are those cuboids. Amazing. So now whenever you change the size of the image, or the resolution, the base plate will also change and give you the accurate outcome. And you can change the thickness of the base plate. Like right now it is 96, which seems a bit too much. Can make it 50. Now it is sleek. But yeah, don't look it from below. Actually, this could be a challenge for you because in the Lego blocks, there are depressions that will get socketed into the base plate. So that's a challenge for you to create those depressions. So just one more thing. Here we've got so many different individual blocks. There is a component called the render node that simplifies some internal computation and allows us to make this process in a very simplified fashion. In the sense, the script is going to probably remain the same, but how the computer looks at it changes using this render node. And so the script will become lightweight and it will become very fast. But that will be covered in the link in the video that will be linked probably on top of me. So check that out and incorporate this render node into the original script which we have discussed. Awesome. Let's just group this back again. So this will become our base plate. Awesome. The link to the script as well as the part A script will be linked in the description below. So check that out and see you in the next one.